All right, guys, this is going to be the lecture for homework 11. This one is, it depends on how you phrase it, but it's either going to be called patterns and progressions. I think that's what I put on the schedule. Officially, you would actually call these sequences and series, but that's sort of an advanced term. Homework 11 is unique in the sense that this is something added by the math department, guys. So first of all, there is no homework help for this in the sense of help me solve this, view an example, anything like that. So this is one you're going to need to refer to the video for examples. The video should contain all the examples you need to see for the homework, meaning like everything that's in the homework should be in the lecture. You can also make sure to use the tutors at the Learning Center or Learning Commons and things like that. Don't save this one for the last night, because if you run into trouble, there will be very little help. I mean, you can always use the online tutoring through Pearson, but you guys have said that the quality there is not the greatest. So it's available to you, don't forget, but this is one you're going to want to kind of get a head start on, all right? So patterns and progressions, which is what I'm going to refer to it as. It is sequences and series, but if you start Googling mathematical sequences and mathematical series, you're going to get into some seriously deep waters. So this is actually a pre-calculus topic. It's not that we're teaching you pre-calculus, but this is something that they go into much, much more thoroughly in pre-calculus. So, you know, it can be advanced, but again, Googling this is going to be trouble, because if you do, you're going to get past what we're talking about effectively immediately. So be a little bit careful. Let's just jump right in so you can see what I'm talking about. I think at this point, I'm just making it a bigger deal than it probably is. What we're talking about is you're going to be given tables in this homework, all right? I don't draw straight lines real well, so, you know, especially with the hand the way it is. So bear with me here, and they'll be labeled like that. You might look at these and think like, oh, that's going to be a bunch of points and we're going to graph them. We will be getting to graphing, you know, down the road. Right now, that is not what we're doing. And so just keep that in mind. We're not graphing here. Heads up. So let's say it looked like something like this. 1, 7, 2, 9, something like that. And then they'd, you know, have a 3 here. Maybe this one would be skipped, and then there'd be a 7 here, and then they'd skip some more, and then they're going to ask you for A. All right. So that's what your homework's going to look like. All right. They're going to ask you, they're going to give you a table. They're going to ask you to fill in certain values. You need to fill this one in. You need to fill this one in. And then the bottom one is going to have a generic variable. All right. So this is what I mean when I say patterns and progressions. So you just need to look this over and kind of identify the pattern and see where it goes. A couple terms, first of all. The left side, and I didn't say A because the variables will change here on every single problem. The left side you want to think about as the count, okay? You're counting. This is 0 steps, 1 step, 2 steps, 3 steps, 7 steps, right? We skip some more, and then we get down to A, which I'll talk more about that in a minute. This is the count, or yeah, this is just the counting value. All right, that's just the counting value. The left side only tells you how many times you've done it. The left side is not the value of the pattern, right? The pattern's over here. We went from 5 to 7 to 9 to blah, 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 blah. That's the pattern. The left side is just the counting value. When you were born, you were 0 years old, right? We start at 0. We aren't born 1 year old. We're born 0 years old. You know, this is not accurate baby weight here or anything, but let's say when you were born, you were 5 pounds. After 1 month, you were 7 pounds, 2 months, 9 pounds, or whatever. That's what we're talking about here. The number of months that have gone by is simply just a count. This is the actual value, okay? So the left side is the counting value. The right side, let's just say count. I like that better. I don't even want the word value in there. We're just gonna say count. The left side is the count. The right side is the value. See what I mean? That's the side we care about. The left side is just a count, how many times you've done it. The right side is the value where the actual pattern is occurring, okay? So by now you've probably already looked at this and figured it out. We're going from 5 to 7. And then from 7 to 9, we're obviously adding 2. Hopefully that's obvious, okay? So then if we went on to 3, well, we'd add 2 more, and that would make 11, right? No big deal. And then they want you to skip a bunch. I mean, they might have you fill 4, 5, 6 and all those out, but a lot of times they're just going to skip some and go to some random number like 7. You know, how you do this is up to you. You can kind of come off to the side and say, well, 3 gave me 11. If I add 2 more, the next step would be 13. If I add 2 more, the next step would be 15. If I add 2 more, the next step would be 17. If I add 2 more, the next step will be 19. Again, remember, adding 2 over here on the value side. I'm just basically extending the table. 3rd step, 4th step, 5th step, 6th step, 7th step, it was 19, right? Take a minute, make sure you're cool with that. Or again, you could just counted it off in your head. I mean, how you get there, it doesn't matter. I'm not going to spend a lot of time today talking about how to fill in the number values, because once you know the pattern, you just continue the pattern until you get the number values. This down here is where my concern lies and where your concern will lie. So what they're asking for here, and this would technically be pronounced ATH, eighth. They're asking for the eighth step. They're asking you not what happens on the first step, the second step, the third step, the fourth step, or the seventh step, or the 100th step, but what happens on any step, right? For any step I give you, A being anything, whether I tell you it's the third step or the seventh step or the 1000th step, I want to know what the value would be. Meaning what they want here is a formula. They want a formula that makes the entire chart, right? Rather than, I mean, because what if they asked you for this 37th step? You don't want to have to sit there and add 2 all these different number of times till you get to whatever you're looking for. Ideally, we come up with a formula here, and that's really the point of the problem, okay? So this is where it gets a little bit weird. The formulas, they do have a generic outline, but it's not super easy to write. It looks something like this. Let's just write this one out, and then we'll talk about it generically. Where did you start? You started at 0, yeah? But what was the actual value when you started? 5, right? When you were born, or whatever this represents, you were born 0 years old, 5. That's where we started, was with 5, all right? Then what did we do? We added 2, and then we added 2 again, and again, and again, and again, and again, right? So we added 2 1 time, we added 2 2 times, we added 2 3 times, and then we just kept doing this, right? Forever, or however many times we needed to do it. How many times did we do it? We did it once, twice, 3 times, 7 times, A times, right? Whatever this A was, that's how many times we did this. So we could say, I mean, this is not the formula, I'm just having you think it out. We could say we had 5 and we added 2 to it A times, whatever A was, whether it was once or twice or 3 or 4 or 5 or 6 or 7 or anything, right? So how could we represent that as a formula? Well, it would be 5, right? Plus 2, but not once and not twice, but however many times we needed to, A times. Wouldn't that just be 2 times A? Think about it for a second. Let's say I asked you to do the third step. Wouldn't that be adding 2 3 times to 5? Well, isn't that 2 times 3 plus 5, right? And let's validate this. Put these numbers in. Here's the thing. Once you have the formula, all of these should be able to be generated from it. So you can check this and know if you're correct. Put in 0 for A. 2 times 0 is 0, plus 5 is 5. It worked. Put in 1 for A. 2 times 1 is 1. 2 times 1 is 2, plus 5 is 7, just like it should be. Put in 2. 2 times 2 is 4, plus 5 is 9, just like it should be. Put in 3. 3 times 2 is 6, plus 5, that's 11, just like we said it would be. Put in 7. 7 times 2 is 14, plus 5 is 19, just like we said it would be. So the formula for this table, which is what would go here, is 5 plus 2A. Okay? Think about that for a second. We'll say more about this in a minute. I just kind of wanted to get one example out so you can see what I mean about patterns and progressions. Okay, again, this is technically a arithmetic series or sequence. But again, I try to avoid using those words just because if you start looking that stuff up online, you're going to get into pre-calc material very quick and get into your head. So be careful. So one more time, how did this happen? We said, and again, I'll write this out generically in just a second, but what I did is I said, well, we started at 5, right? There was nothing before 5. At 0 on the count, which is where numbers start, we were at 5. So 5 was where I started, right? We could say that's the starting value if you want, right? The starting value. Remember, I said the right side is the value. So that's the starting value. And then we just added 2, but we didn't do it once or twice or 3 times or 7 times or any specific number. We did it whatever this A value was. That's how many times we added 2. So we added 2 A times, okay? So let's think about this generically speaking, right? That was called arithmetic. And I know it's spelled the same as arithmetic, but that is not how you say this word, not in this context anyway. Arithmetic. And this is what you call any sequence or pattern that does plus and minus. Okay, if it adds numbers or subtracts numbers, we call it arithmetic. And again, this is not really a generic formula. It's not like something you need to memorize for, future math classes. It's just sort of the way I think about it. What you have here is your starting value, right? That's what we started with. And the last one we started with 5. And then we add or subtract some number, right? In our case, we added 2. and then times the count. Right? And that almost makes it more complicated than it needs to be. But think about it. Go back to what we just did a second ago. Let me bring it up. Right? Think about what we did. We took the starting value, and then we added, in this case, not subtracted, this was an adding, and then we added whatever our number was. In this case, we added 2, so I put plus 2. Then it's times the count. Well, the count was A. Don't put a number in there, right? Because it's not, we're talking generic, right? It's 5 plus 2 times 1 times 2 times 3, however many times you need to do it, and the number of times you need to do it is the, whoops, I'm pointing to something that's not on the page, sorry. The number of times that you need to repeat this cycle is whatever the count variable is. So you take your starting value, you add or subtract your number, whatever that is, and we'll do another example here in a minute, and it's always going to be times the count. So that's how I got 5 plus 2a on the last one, just to reiterate, okay? Let's do another one here. The variables should, oh my goodness, I really don't draw straight lines well at all. It's kind of becoming super apparent on here. Graphing is going to be interesting. It's a lot easier on a whiteboard for whatever reason. So let's say we were given this table, and again, the variables could be A, B, X, Y, N, M, U, F, whatever. It just doesn't matter. Don't pay too much attention to the variable names other than, you know, for filling out the formula. Let's say we had 0 and 14, 1 and 7, 2 and 0, and then they skip a bunch and they'll ask you to fill out the 5th step, which again, like I said, we're not going to spend a lot of time doing that because you could simply just go, well, here's the 3rd step, here's the 4th step, here's the 5th step. You know, that's just a matter of doing the pattern out over and over. And then they'll skip again and they'll ask you for the generic X step, XTH is technically how you'd say that. But again, you can just say generic formula. That last step just wants a formula. So first of all, take a look at it, figure out what your pattern is, okay? Remember, the left side is just the count. The left side is just telling you how many times the pattern has been executed. The left side is simply a count of numbers. The right side is the actual value. So we started at 14, then we went to 7. So be careful. You can't look at the first one and make the call because I could have what? Subtracted 7 to get to 7, or I could have divided by 2. So be a little bit careful here. Make sure you look at all 3 steps. We went from 14 to 7, so maybe I divided by 2, but 7 divided by 2 is not 0, so that's, I didn't divide. So 14 minus 7 gives me 7, and 7 minus 7 gives me 0. So it looks like, yeah, we're subtracting 7. Okay? Now I'm actually going to skip the 5th step for now. I'm going to do the formula first, and then once I have my formula, I can just plug 5 in, and I'll have my number, and I don't have to sit there and do 2 and 3. It's up to you how you do it, though. It doesn't really matter. So we want to come up with a new formula for this chart. So using this sort of generic outline we had up here, what was the starting value on this chart? The value, not the count. The starting value was 14. And then is it adding or subtracting? Well, it's subtracting. And how much did we subtract? 7, right? Subtracted 7. And then here's the part that everyone goofs up. 7, how many times did you do that though? You subtracted it once, twice, 3 times, 4 times, 5 times, this many times, right? This over here is telling you how many times you subtract 7. If it's 0, it's 0 times. It's 1, it's 1 time, 2 times, 5 times, X times, because that's what the count is. You had 14 and you're subtracting 7 from it, X times. Whatever X is, whether it's 0, 1, 2, or 5, that's how many times you subtracted it. And so that would be your formula. Now you could write this as negative 7x plus 14, and the computer should take it. I don't know why you would write it like that. It's kind of weird to build it up like that, but it is acceptable. This is the way, I would generally expect you to do it. But just understand, it should be this, as long as you enter an equivalency, it should work. So if you enter something you think is right and the computer's showing you something that you think is the same thing, make sure you send me a photo of it with a screenshot so I can look at it, okay? So let's go ahead and figure out what the 5th step would be based upon our formula. Actually, let's check the formula before we do that. Sorry, I'm jumping the gun. Let's make sure we have the formula correct first. Let's plug in 0 to our formula. Negative 7 times 0 is 0. 14 minus 0 is 14, just like it should be. Let's plug in 1. 14 minus 7 times 1 is 7. 14 minus 7 is 7, just like it should be. Plug in 2. 2 times 7 is 14. 14 minus 14 is 0, just like it should be. So if it gets all 3 of those, then we have the correct formula. All I need to do now is plug in the 5. So 14 minus 7 times 5. 14 minus 35, right? Don't forget your basics. We have a positive and a negative number. If you need to do it out, do it out. You don't have to do this in your head. No one's asking you to. 21, positive or negative? Well, it'd be negative 21, right? Because the bigger one's negative. And there's spot 5 filled in for us. So how you do these is up to you. If you just want to sit there and go, well, 0 minus 7 would be negative 7, minus 7 would be negative 14, minus 7 would be negative 21, that's fine. But you will need to come up with this generic formula here. So keep that in mind. Sometimes it's easier for people to come up with the formula first and then fill out the pattern, okay? So let's do another example here. Remember, like I said, this is arithmetic. Arithmetic is plus and minus patterns. We do have to talk about a division and multiplication here in just a second. All right, so let's say, let me try to keep this somewhat straight. That was not a good job. It's a little better than last time, I guess, right? Let's say I said, we'll just do a couple this time. Let's do 0 and negative 6, 1 and negative 9, 2 and negative 12, and then we'll just skip straight down to the formula, because I think that's what most of y'all are gonna have issues with. Filling out the table won't be the issue for most of y'all. I mean, you know, once you identify the pattern, you can sit there and do that as many times as you need to. It's gonna be that last bit, the formula is where most people are gonna need help. So remember, just to write it again, arithmetic is for plus and minus. The only reason I tell you the name is just to help you keep it straight. It's not something I'm going to test you on. I'm not going to say, oh, you know, is this an arithmetic formula or not? You know, maybe in a traditional class I would, when we spent more time going over questions and things like that. But here you're just getting kind of a boiled down version. So we have to keep it straightforward as possible. So don't worry too much about the name. I'm just telling it to you so you can keep it straight from the other kind, which we'll talk about in a minute. It's always good to have labels for that kind of stuff. But it is just a name. It is just a name. So arithmetic is the plus and minus sequence. And arithmetic, like we said, have the starting value. Then you're either going to add or subtract some number depending on what your formula is doing. And you'll do that number however many times the count was, right? Just like we said last time. Again, I don't necessarily think that's the greatest way to write it out, but it kind of is what it is. That is sort of the structure. So what are we doing here? 0, negative 6, 1, negative 9, 2, negative 12. Well, hopefully you see that we are subtracting 3, right? Because think about it. It's just getting more negative. Negative 6 and then negative 9 and then negative 12. It's just getting more and more negative. So it can't be adding, right? If you're only getting more and more and more negative, it's got to be subtraction. If it's getting more and more and more positive, then it's got to be addition. So we're subtracting 3. Hopefully no big deal there. Let's think about what this formula would look like. What was the starting value? The starting value was negative 6 right here. The value, because again, remember, the right side is the value. The left side is simply just a count. So our starting value was negative 6, right? Then we subtracted 3. That's the number, right? We added a number or subtract a number. We subtracted 3. And we did it how many times? Well, what was the count here? C. So C times. Negative 6 minus 3C. Okay? Hopefully that's getting a little bit clearer, a little bit easier for you. So that should be enough examples for you to get any of the plus minus ones done, because they're all the same. That's the thing about this unit. It's annoying because it's added by the math department, so your textbook doesn't have any of the learning aids you normally have, like, you know, help me solve this stuff like that. But once you learn the pattern, they're all kind of the same. So that's the nice thing about this. You know, once you figure it out and get comfortable with the little formula here, they're all the same. Validate this, plug in 0. 3 times 0 is 0. Negative 6 minus 0 is negative 6. Good to go. Plug in 1. We should get negative 9. Negative 6 minus 3 times 1 is negative 3. Negative 6 minus 3 is negative 9. Good. Plug in 2. We should get negative 12. Negative 6 minus 3 times 2. That's negative 6 and negative 6. That's negative 12. So if your formula, is giving you all of the values on the table, you know you have it correct. So that's, again, that's the wonderful thing here, is you'll know if you're correct or not. All right? So that's the adding and subtracting, 3 different examples there. And again, feel free to, you know, or don't feel free, I would encourage you to come back to the lecture later. If you're having trouble in the homework, view the examples again, you know, try to work them out side by side. This should cover it. This homework is pretty one-dimensional. It doesn't have a lot of different aspects to it. All right. So we've talked about what a plus and minus sequence might look like. Now we're going to talk about what a geometric, well, meaning a multiply or divide sequence would look like. All right. These are a little bit trickier. Not much. If you understood the last few, this will make sense. If not, go back and rewatch the last 3 examples. Don't move on until you understand those. Okay. So let's start with just, again, a normal table here. We'll do U and V. And it does need to start at 0 if they want you to come up with a formula. There might be a couple of problems where they don't start at 0, but then they will not ask you for a formula. They would simply just ask you to fill in the table. Let's say we said 0 and 4, 1 and 8, 2 and 16. Skips a bunch, asks you for the 8th step, skips a bunch, and then asks you for the youth step, UTH. Again, really, you can just say the generic formula, okay? So again, how you do this is totally up to you. First, you want to identify the pattern. Adding 2, or excuse me, multiplying by 2 looks like it might be, right? 4 times 2 is 8, but be careful because you can also get to 8 by just adding 4. 4 plus 4 is 8, but 8 plus 4 is not 16, so we're not adding 4. 4 times 2 is 8, and 8 times 2 is 16. So it looks like what's happening here is we're multiplying by 2, right? And then you can just keep going, right? Multiply this out as many times as you need to fill out the 8th step. Now, the formula here is a little bit different. So what would it be? Let's think about the formula here. First of all, the nice thing is it's still the starting value, just like the last one. So we started this whole table at 4. You always start with the starting value. This is what you started with. So we started at 4. Now we're not we're not adding or subtracting anymore. We're multiplying and dividing, right? So we took 4 and we multiplied it by what? 2. We did that one time. Then we did it again. Then we did it again and again and again and again. You multiplied by 2 as many times as you were told to, right? Whether you did it once or twice or 8 times or U times. Does that make sense? You're taking 4. The only difference is we're not adding it. We're multiplying, right? We took 4 and we multiplied by 2 once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, however many times you told us to. So how could you write that as a formula? It'd be 4 times 2. How do we write 2 a bunch of times? Think about it. If I had 2 times 2 times 2 times 2, wouldn't that be 2 to the 4th? Well, you have 2 times 2 times 2, and it's not 4 times or 5 times, it's U times. So it'd be 4 times 2 to the U. So the only difference really here is that it's not plus and minus, and the power, the variable isn't a power. So if we were going to write this sort of in a generic format, I'd say it's the starting value times the number, whatever you're multiplying by, and then the count variable will be as a power this time. That's the big difference with geometric from arithmetic, okay? Remember, let's see if I can get both of these in on the same page here. Back to the stuff we did at the beginning. The arithmetic is different, remember, right? Arithmetic is the starting value, then you add or subtract your number times the count. Geometric is the starting value times the number to the count. Right? It's a little bit different, so make sure you see that. Okay? So here we have 4 times 2 to the U, and you just work it out. Plug in the 8, plug in the 2, plug in the 1, plug in the 0, plug in whatever numbers you want. Let's go ahead and validate that this formula does work. Plug in 0. 4 times 2 to the 0. 4 times 2 to the 0. What's anything to the 0? We just talked about this last week. That's 4 times 1, which is 4, just like it should have been. Now here we have 4 times 2 to the first. So 2 to the first is 2, right? 4 times 2 is 8, just like it should be. Now we'll do it times 2 again. 4 times 2. Now this time we're on the second step, so the power is 2. 2 squared is 4. 4 times 4 is 16, just like it should have been. Again, if you can make all 3 of the initial starting numbers with your formula, you do have it correct. So the main issue here is the power. Okay, the main issue here is that the variable, the count variable, it's not 2 times U, it's 2 to the U because we're already multiplying. All right, so whether you memorize that or whether you reason it out is up to you, but it's a little bit different from arithmetic. Okay, let's do a couple more examples. All right, there we go. Let's say E there. All right, so here's another table. 0, -3, 1, 6, 2, -12. Right off the bat, you can go ahead and tell that this is geometric. How? How do I know that? I mean, obviously I made the problem up, but how do I know this is geometric just by looking at it? Remember, geometric means what? The arithmetic is for addition and subtraction tables. Geometric is for multiply and divide. I can tell you this is not adding and subtracting right away. How? Look at the signs. How do you go from negative to positive? Well, you could have added a bunch of numbers and brought it up, but then how did you go back down, right? Here we're going up to 6 and then back down to -12. You don't get up and down from adding. If you add, it only gets bigger. If you subtract, it only gets smaller. The fact that we're bouncing around from negative to positive to negative, that tells me it has to be division or multiplication, okay? So just another little tip, if it's not going in one direction, then it has to be multiplication or division. If it's always increasing, it still could be multiplication, but it could be addition as well. You have to be careful. If you bounce back between negatives and positives though, you don't do that by adding and subtracting. It either goes positive and stays positive or goes negative and stays negative. It's only gonna change once, not back and forth. So just something to think about. So what do you think's happening here? How did we go from -3 to 6? Well, I might have added 9, right? I might have said -3 plus 9 is 6. But 6 plus 9 is not -12, so I didn't add 9. How else might I have gotten from -3 to 6? I might have multiplied by -2. Does that work here? From 6 to -12. Yeah, multiply by -2. So it can be a negative, y'all. Be careful. Again, if you want to fill out the 5 right now, we can do it, or we can do the formula. It's up to you. If this was the third step, you'd multiply by -2 again and get positive 24, right? If it was the fourth step, you'd multiply by -2 again and get negative 48, right? And it was the fifth step, you'd multiply that by -2 again and get positive 96. Take a minute, make sure that makes sense to you. Sometimes the formulas here are a little bit complicated. It might be easier to just do the formula out a couple of times. So let's find our formula. Remember what we said last time. It's the starting value, except this time it's going to be times some number, not plus or minus, and it's going to be raised up to the count, because when you're doing geometric, it's going to be as a power. Starting value in this case was -3. Then we multiplied that by -2. And how many times did we do that? 0 times, 1 times, 2 times, 5 times, E times. We did that E times. So your formula here would be -3 times -2 to the E, okay? This is a little bit different, guys. This is probably going to be the most different material you've had, all right, in the sense in this class of, you know, you've seen addition and subtraction before. You know what LCM and GCF were, even if you hadn't really done much with them before. This might be the first thing in the class that's like completely alien to you. You know, it's okay if you need to watch the video twice or even more than that. Now, we haven't done one with division, so let's go ahead and do that. Let's go ahead and get that out of the way. My goodness, I'm gonna have to get a ruler or something. These lines are just ridiculously bad. All right, so let's say we had this table here, and again, it's gonna start at 0, really kind of needs to, and let's say it was 125, right? Could be a big number. We've been using small numbers, but there's no guarantee it'll stay that way. Let's say the next one was 25, and the one after that is 5. And then they just skip a bunch and they just ask you for the formula. You might have to fill more in on the table later, you know, who knows. But again, you can do that. You can, once you know the pattern, you can sit here and keep going with the table. All right. So what's happening here? I mean, I already told you this is division, so I kind of gave this one away. But how would you know that? How did you go from 125 to 25? 2 ways. You might have subtracted 100, right? 125 minus 100 is 25. But 25 minus 100 isn't 5, right? So we didn't subtract 100 because it has to be the same both times. Well, how did you go from 125 to 25? You may not even really know, but how did you go from 25 to 5 if you didn't subtract? Didn't you divide by 5? And if you go back and look, 125 divided by 5 is 25 as well. All right? So be careful. Division can be a little tricky. Now, here's the thing, and here's what people, I mean, they like it, but they don't like it at the same time. The formula for geometric, when we wrote it out a second ago, looked like this, right? Starting value times some number to the count. Notice I didn't write division here. This is the formula for geometric no matter what. So what that is saying is we don't write division as division. We need to write it as multiplication. It's a little bit annoying, and this is probably the trickiest part of this, so pay attention here. What I would do is the following. Start it out as you normally would. Our starting value was 125. Then what did you do? You divided by 5, you divided by 5. So just go ahead and write that first. Because it is division. You are dividing by 5. It's not, you know, it is what's happening. And how many times did you do it? 0 times, 1 times, 2 times, y times. And remember, when we're doing geometric, the count variable goes up as a power. So that is your formula. The problem is you've written multiplication and division in the same step, right? Parentheses next to each other means multiplication, but you wrote it as division. So here's the trick. How can you write this as multiplication? Think back. We've actually already talked about this. When did we take division and rewrite it as multiplication? When we did fractions, yeah? Just for a second off to the side here. Let's say I said 1/2 divided by 3/5. Don't you take it, change it to times, and flip the second fraction? Isn't that what we did, right? Well, that's what we're going to do here. We're going to keep the first one. We're going to change it to times, meaning we're going to drop the division symbol, and I'm going to flip this number to 1/5. That's what this would look like, because multiplying by 1/5 is the same thing as dividing by 5. So what you got to be careful with, geometric cannot be written with division. Even if it is division, you've got to write it as multiplication by flipping your division into a fraction. That's the tricky part here. That's the part everybody gets confused with. Be careful about that. All right, let's do another one here on the same page. And I might end up using some of the same variables here because I'm not super original. Let's do 0 and 3, 1 and 1, and 2 and 1/3. And then we'll ask you just for the generic step A. All right, it's just a nice little short table here. 3 steps, and then I'm just asking you to go ahead and skip to the bottom and give me the formula. 3, 1, 1/3. Be careful here. How did you go from 3 to 1? Well, you might have subtracted 2, but you didn't subtract 2 to get to 1/3, so that's not it. 3 into 1, you might have divided by 3, right? Now think about the fraction. It's sort of giving it away. It's kind of giving it away. You had 1, and now you have 1 divided by 3, or 1/3. You had 1, and now you have 1/3. So, I mean, isn't it clear that you must have divided by 3? So what would this formula look like? Well, we started off at 3. Then we divided by 3, right? Like I said, write it as division first if it helps. And then how many times did we do that? 0 times, 1 times, 2 times, a times, and because it's geometric, the a goes up there. Now remember, we can't write this as division really, so what we need to do here is say it's 3 times and flip it to make 1/3 to the a. Okay, like I said, plugging back into this formula can be a little tricky, so if you have to fill out more slots on that table, you might just want to keep dividing by 3. All right? And that's really it, guys. Let's go ahead and do 2 more examples here. I won't tell you what they are. I'll just give you 2 tables. You work these out on your own. But that's really it. The tables are either plus and minus, or the multiply and divide, and you just have to be comfortable with either one. All right? So I'll give you 2 tables. I'll go ahead and just write them out in their entirety. Take a minute, pause it, try to do these on your own. Let's see here. All right, there's your first one. Let's do, and we'll do one over here. Again, don't clown me for my lines. I don't know. I'm like that kid in kindergarten who couldn't cut straight lines and needed special scissors, you know what I mean? Let's see here. Trying to make one that's not too crazy here. All right, there we go. 2 tables. This one says 0, -12, 1, -5, 2, 2. This one says 0, 12, 1, 3, 3/4. And then in this case, I want to know what the x step is, and I want to know what the 8th step is, meaning I want to know what the 2 formulas are. All right, so pause it, take a minute, see if you can work these out on your own, and we'll do them together. The first one here, you look and say -12 to -5. Well, 12 times nothing makes 5 easily anyway. So probably I'm adding, right? To go from negative to less negative, yeah, you owe me $12. Now you owe me $5. Most likely you gave me $7, right? You added $7 to the account. Then you went from -5 to $2, meaning you added $7 again, right? So I think we can say here we're adding 7, so that's good. So what would our formula be for this one? Well, the starting value would be -12. Remember, this one is different. This is arithmetic. This one here is arithmetic, meaning you're adding and subtracting. So in this case, we added 7, 0 times, 1 times, 2 times, x times. And when it's arithmetic, the x just sits down there, or the count just sits down there. So -12 plus 7x. Again, go ahead and plug in the numbers to validate that if you need to. Okay. Now the second one over here, we went from 12 to 3. So I might have said -9, right? But 3 minus 9 is not 3/4. So I did not subtract. What's the only other way to make things smaller? To divide them. So 12 divided by 4 makes 3. And again, if you kind of look here, it sort of gives it away. You had 3, and now you have 3/4. You had to have divided by 4. There's no other way to get that. So you're dividing by 4. So this one here is geometric. So our starting value was 12. Then we divided by 4. And like I said, at least the first few times you do this, go ahead and start it right off as division, even though we can't leave it like that. And then how many times did we do that? 0 times, 1 time, 2 times, 3 times, 4 times, blah, 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 a times. And because it's geometric, it goes up as a power. The last step is to convert this away from division. So it'll be 12 times, and we convert division by flipping it, and then a power. So 12 times 1/4 to the a, and that would be your formula for that. So again, guys, I would recommend watching the video maybe a couple times, not necessarily one after the other, but try it, go do the homework. If there's a couple you're stuck with, come back, look through the examples. You can email me, but do remember to show me a screenshot of your work or a photograph of your work as well, so I can see where you're going wrong, okay? Don't save this one till the last minute, guys. There is no textbook help available on this one because this chapter is not out of your textbook. This is something the math department added to prepare you for MGF 1106 and 1107. So get working on it earlier, get up with the tutors, or let me know if you need help, and I'll see you guys in the next one.